Good morning, students. Today we are going to start carbon and its compound. We know that the whole compounds have been categorized in two groups: organic compounds, also called as carbonic compounds, and inorganic compounds, which are non-carbonic compounds. The name organic compound has been given so because the scientists believe that carbon compounds are found only in living beings. It means organism is the living beings, as the carbonic compounds are found in organisms, so they were called organic compounds. It was believed that organic compounds cannot be created in a lab. It was called vital force theory. According to vital force theory, organic compounds exist only in living being and it cannot be produced in laboratory. But after the formation of urea in the lab, this myth was completely obsolete. And now we can prepare so many organic compounds in the lab. So let us first start it with carbon. Atomic number of carbon is 6. Electronic configuration of it is 2 electrons in K cell and in L cell there are 4 electrons. It is found in 14 group of period 2. Naturally, carbon has so many compounds. What is the reason behind this? What are the reasons of the abundance of organic compounds? The reasons for organic compounds are: number 1, catenation; number 2, tetravalency; number 3, isotopic existence, and number 4, a small atomic size. All these properties are found in carbon. First of all, let us know what is catenation. Self-linking property of an atom to the other atoms of itself to a long number is called catenation. Carbon can add other carbon atoms to a very long number, and this capacity is found only in carbon, though silicon can add up to some number of silicon atoms, yet after that no more compounds can exist. Sulfur can also exist up to 8 atoms of sulfur in ring, but after that it too does not exist more compounds. So it is catenation is one of the property of carbon, due to which there are so many numbers of organic compounds. Next one is tetravalency. It is not so that only carbon has valency 4. There are also other atoms like silicon which has valency 4. But carbon has both catenation and tetravalency. One carbon atom can add up to it 4 different types of atom of single valency, other atoms of valency 2, another of valency 3. So it increases the number of organic compounds. But this two properties altogether are not found with other atoms. The third one is isotopic existence. We know that there are two isotopes of carbon, carbon 12 and carbon 14. So organic compounds can be found with carbon 12 and carbon 14 as well, and this is why the number of organic compounds increases. The fourth is a small atomic size. It is not so that there is no atom which is smaller than the size of carbon, but this is the size of carbon is not so big, so it can easily be embedded in the nucleus of other atom, and therefore stable compounds can be formed. Let us now proceed. So this is one of the important question which is liable to be asked in the examination, the reasons for the abundance of organic compounds. Let us now proceed for allotrophs. Allotrophs. What are allotrophs? Allotrophs are the different forms of the same substance. Allotrophs are the different forms of the same substance which have similar chemical properties but different physical properties. There are allotrophs of carbon as well. We must know that graphite, diamond, Buckminster fullerene, and so many substances besides them are the allotrophs of carbon. Of them, the most important and useful allotrophs are graphite and diamond. Similar chemical properties means when we burn carbon, it forms carbon dioxide. It means when we burn graphite, then it too forms carbon dioxide. When we burn diamond, then it also forms carbon dioxide. When we burn Buckminster fullerene, then it also forms carbon dioxide. This is the meaning of similar chemical property. But physical property are different. Graphite is formed layer by layer. It is slippery, it is soft. Diamond is hard. Buckminster have different physical property. So allotrophs are those forms of a single substance which have similar chemical property but different physical property. After allotrophs, let us now learn. After allotrophs, let us now learn the covalent bond which is generally found in organic compounds. We must know that there are three types of chemical bonding: electrovalent bond or ionic bond, covalent bond and coordinate bond. In electrovalent bond, we have studied in the chapter metals and non-metals, and now here in organic compound chapter we will study about covalent bond. To learn covalent bond, first of all we must know the atomic number of the atoms, its electronic configuration and then its valency. Most of them, the important one are hydrogen, whose atomic number is 1 and electronic configuration is this. Then it is carbon, whose atomic number is 4, electronic configuration is 2, atomic number is 6 and electronic configuration is 2, 4. Then we have oxygen, nitrogen. The atomic number of nitrogen is 7, electronic configuration is 2, 5. The atomic number of oxygen is 8, electronic configuration is 2, 6. The atomic number of chlorine is 9, the electronic configuration is 2, 7. We have then chlorine, atomic number 17, electronic configuration 287 Ka. Similarly, sulfur atomic number 16 286, phosphorus atomic number 15 28 and 5. So this is the electronic configuration of some of the important non-metals. With electronic configuration, we must learn the valency of that substance as well. Hydrogen has valence electron 1 and its valency is 1. Carbon has valence electron 4 and its valency is 4. Nitrogen has valence electron 5, its valency is 3. Oxygen has valence electron 6, its valency is 4. Chlorine has valence electron 7, its valency is 1. Chlorine has valence electron 7, its valency is 1 as well. Sulfur, its valence electron is 6 and its valency is 2. Phosphorus, its valence electron is 5 and valency is 3. What is the utility of valence electron and valency? During the covalent bond in general rules, what happens? The atom shares as many electrons with other atoms as is its valency. For example, hydrogen will share 1 electron of its 1 electron, carbon will share 4 electron, nitrogen will share 3 electron of this 5 electron. We must learn that only valence electrons participate in the bonding. So nitrogen will share 3 electrons of the 5 valence electrons, oxygen will share 2 electrons of the 6 valence electrons, chlorine will share 1 electron of the 7 valence electrons, chlorine will share 1 electron of the 7 valence electrons as well, sulfur will share 2 electrons of the 6 valence electrons, phosphorus will share 3 electrons of the 5 valence electrons. After sharing the electrons in some atoms, some electrons are left of the valence electrons. Those are called lone pairs of electrons. For example, hydrogen does not have any lone pair of electrons because it will share all the 1 electron. Carbon does not have any lone pair of electrons because it will share all the 4 electrons. Nitrogen has 1 pair of lone electrons. Oxygen has 2 pair of electrons because out of 6 it will share 2 electrons and 4 electrons will be left, which will be 2 pairs. Similarly, chlorine will be left with 3 pairs of valence electron after sharing only 1 electron of these 7 valence electrons. Remaining 6 electrons means 3 pairs of lone electrons are left. Similarly, chlorine will be left with 3 pairs of lone pairs of electrons. Sulfur will be left with 2 pairs of lone pairs of electrons. Phosphorus will be left with 1 pair of lone pairs of electrons. While deciding the bonding, let us first of all count all the valence electrons in a compound. For example, formation of hydrogen gas. Its formula is H2. It means there are 2 atoms of hydrogen, and as we know that 1 atom of hydrogen will share 1 electron. Sharing must be equal. It is not so that 1 atom will share 1 electron and other will share more than 1 electron. Sharing must be in equal numbers. So if there are 2 atoms of hydrogen, 1 atom of hydrogen will be given by this hydrogen, another electron will be given by this atom of hydrogen. So in this manner there will be 1 pair of shared electron. On this 1 pair of shared electron, both the hydrogen have equal right to use it. we draw a circle around one hydrogen atom and this another one hydrogen atom, and the shared electron must be written in the common part of the intersecting circles. It means during the formation of hydrogen gas, one electron from each hydrogen atom will be shared, and thus there will be single bond between hydrogen and hydrogen atom. Actually, there are three types of covalent bond. Single covalent bond, in which there is sharing of one electron. Double covalent bond, in which there is the sharing of two electrons. Triple covalent bond, in which there is the sharing of three electrons. Let us move ahead. Formation of oxygen gas. Formation of oxygen gas, O2. There are two atoms of oxygen in one molecule of oxygen. We must know, and we have just learned, that there is 6 valence electrons. 6 valence electrons in oxygen. Of them, 2 electrons will be shared because the valency of oxygen is 2. So out of these 6 electrons, 2 electrons will be shared by each atom of oxygen. This will be written here, 2 electrons from this oxygen atom and 2 from this oxygen atom. Because oxygen atom, after sharing the electrons, it is left with 2 pairs of valence electrons. This will be written on any 3 sides of this, either up or down or towards the right. Similarly, this oxygen atom also has 2 pairs of electrons. So in this manner, if we circle one oxygen atom in one circle and another oxygen atom in another circle, we see that in the common region there are 4 electrons, and in one circle we see that there is 8 electrons in each circle. What happens in covalent bond? As in electrovalent bond, atoms try to obtain the electronic structure of its nearest inert gas. In this manner, even in covalent bond, after the sharing, the total electrons in one atom becomes equal to the total number of electrons to its nearest inert gas. So far as we see, when we see for hydrogen atom will have 2 electrons in all after sharing. This is the number of electrons in helium, which is an inert gas. Similarly, in formation of oxygen gas, after the sharing, this oxygen atom has 8 electrons in the outermost orbit. It means 2 electrons in K shell and now 8 electrons in L shell. Total number of electrons is 2 plus 8, 10, which is the total number of electrons in neon. Neon is the nearest inert gas to oxygen gas. Similarly, we can see formation of nitrogen gas. Formation of nitrogen gas with formula is N2. The sharing will be shown. We know that atomic number of nitrogen is 7, electronic configuration is 2, 5. It means 2 electrons in K shell and 5 electrons in L shell. Its valency is also 3. It means out of the 5 valence electrons, nitrogen atom will share 3 electrons. So each nitrogen atom here will share 3 electrons, and each nitrogen atom is left with 1 pair of lone electrons. In this manner, when we circle nitrogen atom in one circle and this nitrogen atom in another circle, we find that in each circle there are 8 electrons. And if we count the total number of electrons, we find that the total number of electrons in nitrogen becomes also 10, which is equal to the total number of electrons in neon. It means during the formation of nitrogen gas 2, the atom has obtained the structure of nearest inert gas neon. This is the rule which is always followed even in the molecule where there are different types of atoms. So far we have drawn the electron dot structure of formation of covalent bond in the like atoms. in the like atoms. For example, in hydrogen there are two atoms, both are hydrogen. In oxygen molecule there are two atoms, both are oxygen. In nitrogen gas there are two atoms of nitrogen. Let us now go for the different atoms to form covalent bond. Now we talk of the formation of water. Formation of water. Its formula is H2O. It means there are in all three atoms two atoms of hydrogen and one atom of oxygen. We will place oxygen in the middle and hydrogen on the side of the oxygen. As the valency of oxygen is 2, oxygen will share 2 electrons, but its surrounding atoms is hydrogen, which will share only 1 electron. There should be equality in sharing. So 2 atoms of oxygen will be shared, but not alone with one hydrogen atom. One electron of oxygen will be shared with 1 electron of one atom of hydrogen, and the remaining 1 electron of oxygen will be shared with 1 electron of another hydrogen atom, like this. Here both hydrogen and oxygen will give 1 electron to share. Here also both oxygen and hydrogen will give 1 electron to share. As oxygen is left with 2 pairs of electrons, non-sharing electrons, we will put those 2 pairs of non-sharing electrons here. In this manner, if we draw a circle around both the hydrogen and oxygen atom, we find that in the circle of hydrogen atom there is 2 electrons, which is the total number of electrons of the inert gas helium. In the circle in which oxygen has been surrounded, there are 8 electrons and oxygen has 2 core electrons. Then total number of oxygen becomes here 10, which is equal to the number of electrons of neon. In this manner, there is a sharing. Hydrogen, oxygen is bonded with single bond, and another hydrogen as well is bonded with single bond. We can also take the examples of carbon dioxide, formation of carbon dioxide. Formation of carbon dioxide, CO2. In formation of carbon dioxide, we will put carbon in the middle and oxygen on the either side of carbon. Here the valency of carbon is 4. It means carbon will share 4 electrons. Of them, 2 electrons will be shared with 1 atom of oxygen, and the remaining 2 electrons will be shared with another atom of oxygen. In this manner, we can see here that this 2 electron is from oxygen and this 2 is from carbon. Here also 2 from carbon and 2 from oxygen. Oxygen is left with 2 pairs of unshared electrons, which will be placed here, and in this also 2 pairs of electrons will be placed here. If we circle oxygen atom and carbon atom, we find that in each circle there are 8 electrons. In this manner, the total number of oxygen along with core electrons become 10, which is equal to the electrons of inert gas neon. And in carbon, in this circle we can see 8 electrons and it has 2 core electrons, so it too has 10 electrons equal to the electrons of the nearest inert gas neon. In this manner,